Nice, now the paper's white. It was orange in the last video. You too, Amanda. Alright, so here's 15 recording. Here's 15. Counting the bacteria culture was 800 after 10 minutes and 1300 after 35. Assuming the count grows exponentially. I personally don't care how you do this. I really don't. I'm not my open math. You can use PERT, or you can do this one. Or you can use a b to the x. I don't give a rat's rear end which one you use. I personally am going to use that one, although I'm starting to like this one. I really am. The problem is, in Tennessee, this is the one we give kids on their end of course test, so that's the one we're going to use in Tennessee. So what was the initial size of the culture? You know, I'd rather use this. It just makes more sense. There's more variables than p times 1 plus r to the t. So we got 810. It's the order pair 10, 800. And then we got the order pair 35, 1300. So we'll just use y equals a b to the x. And we'll plug stuff in. 800 is a times b to the 10th. I'm going to make that uppercase b. And the other one is 1300 equals a times b to the 35th. And then you just solve one of them for a. You just take the first one and solve it for a, you'd have a is 800 over b to the 10th, which is cool because everywhere you see an a, you can just plug it in. So 1300 equals 800 over b to the 10th times b to the 35th. And cleaning it up a little bit, we get 800 b to the 25th. God, this thing's going to be horrible, isn't it? It's going to be really, really ugly. Anyways, 13 over 8 is b to the 25th power. So, take 13 over 8, raise it to the 1/25th power, and there is my b value. That's per minute, by the way. B is about 1.0196. And again, I'm not my open math. 4 decimal places is fine. So here's my equation. Well, sorry, after I get A is 800 divided by that b to the 10th. And I'm going to use the exact thing in the calculator here. A is about 658.792. All right, so the initial size of the culture here is going to have to be rounded up 659. We round up life forms, okay? 659. Find the doubling period. The doubling period happens when this becomes 1318. So the population is 1318. It ought to be really close to 35 minutes, right? 35 was 1300. It's got to be right at 35 minutes. But we have all of our stuff here. Our equation now, because we rounded up the life forms, is 659 times 1.0196 to some time or some x value. And I want to know when it's going to be 1318. Divide out that 659, I should get 2. ln both sides. That has a natural log of 2 divided by the natural log of that funky looking decimal. And that is roughly my time. $35.71 minutes. If you like seconds, take your 0.71, multiply it by 60. Roughly 35 minutes, 43 seconds. Depending on how you round. You might have had 44, you might have had 42. It's not that big a deal. Find the population after 120 minutes. That's just taking your little equation and plugging it into 120. Seeing what she generates. And if you round different than I do, obviously you and I are going to have different things. Just show me your work so I can see how it was done. So that's a life form 6,769. And when does it reach 13,000? I don't think you guys are going to have an issue with that. You guys have gotten pretty good at this stuff. Take your 13,000, you set it equal to your original 659, 1.0196 to the T, and then crank it out. 13,000 divided by 659 is not a very pretty decimal, especially when you don't type it in the calculator right. So I'm not going to do anything with it. It's just 13,000 over 659. And we'll ln both sides. But anyways, the time is going to be the natural log of 13,000 divided by 659, sitting over 1.0196. There you go. Weird. Why did I get 3 minutes? Something seems really wrong with that. Did I do too much at once? Oh, I'm a moron. That's what's wrong. I forgot the ln right there. Don't do math when you're this tired. Took me a second. That's better. About 154 minutes. Okay, so that's about all the time I got on this little video. I will do some more recording during lunch.